Welcome back to a video on my channel by _exe. Today we're going to look at more examples of linear equation problems. So here's question 1 of this video. We need to solve each of these equations. So let's start off with part A. Well, first you may notice that you can just distribute 1 over 4 into these. So you get 1 over 4 times 4x, which is just x, minus 1 over 4 times 8, which is 2. Now on the right hand side you can just do the same, just distribute these, you get 6x plus 3. And perhaps we can subtract 6x on both sides to get negative 5x. And then we can also add 2 on both sides to get 5 on the right hand side, and you'll get x is equal to negative 1. For part B, now these type of questions are categorized as rational equations, and when they're dealing with rational equations with some expressions in the denominator, first you must know one thing. The denominators of these fractions cannot be equal to 0. So each of these cannot be equal to 0. So, well, we can just set each of these equal to 0 to find the disallowed values of t in this case. So by setting t squared minus 25 equal to 0, you get that t is equal to plus or minus 5. Same thing for the others. T minus 5 equals 0, you get t equals 5. T plus 5 equals 0, you get t is equal to negative 5. So the criteria for the denominators in this case is t cannot be equal to negative 5 or positive 5. So that's the clue here. After you find out the disallowed values for t, well, you can just work things out normally as you do normally. So I'll just multiply both sides by t squared minus 25 to get rid of the numerators. So the left hand side will be just 2t. On the right hand side it will be t times t plus 5 minus t times t minus 5. After you multiply that by t squared minus 25. And how do you get these numbers? These expressions? Well, you know that t squared minus 25 is actually a difference of 2 squares, and you can just factor these out. So t plus 5 and t minus 25, which is a very nice expression since each denominator has at least one of them, so one of them cancels out very nicely. So yeah, that's the whole point of this factorization. And from here, you may be worried that you were doing with quadratic equations, but don't worry. The t squareds will eliminate each other nicely. So 2t will stay the same. We can distribute these, so we have t squared plus 5t. So negative t, distribute that into these expressions. So we have t squared plus 5t. And as I've said before, the t squares will cancel out, and you're left with 2t is equal to 10t. Well, you can just subtract 2t on both sides to get 8t is equal to 0, and you'll get that t is equal to 0. And after you get this, you must check if this solution is a part of the disallowed values of our denominators, which are 5 and negative 5. And obviously 0 is not equal to plus or minus 5, so this value is therefore a solution. So we're done with question 1. Let's jump into question 2. Alright, so for question 2, this is a word problem. Given two numbers such that one is 5 times the other. So we have a larger number that is 5 times a smaller number. If those two numbers are both added by 1, the larger number will be 4 times the smaller one. Find the value of the larger number before added by 1. So it's the original value of the larger number. So let those numbers be A and B, with A being the larger one. And from the first sentence, we can notice that A is equal to 5 times B, since A is 5 times the other number, which is B. And from the second sentence, it says if they are both added by 1. So let's see. If we have A plus 1 and then we have B plus 1, the larger number will be 4 times the smaller one. So it will be 4 times this whole thing. So let's see. We need to find the value of the larger number before added by 1, which is the value of A here. Well, notice that we can just substitute the fact that A equals 5B into this A. So we will get 5B plus 1. Go to where we can just distribute that. We get 4B plus 4. We can just subtract 4B on both sides and subtract 1 on both sides. You'll get B is equal to 3. And substituting back into this property, you get A is equal to 15. So this is the value of the larger number before added by 1. And if you check that, if you add 15 and 3 by 1, so let's just see this, you'll get 4 and 16 respectively, which are, well, which we know that 16 is 4 times 4. So yeah, that is question 2. And let's jump into question 3. And for question 3, it is yet again a word problem. So an apple costs half a dollar more than an orange. John pays $19 for 5 apples and 6 oranges. Find the cost of 6 apples and 7 oranges. Well, you can just design this as a problem involving 2 variables. So let's just suppose the cost of an apple is x and the cost of an orange is y. And from the first sentence, we know that x minus 0.50 or just 0.5 is equal to y, since an apple costs $0.5 more than an orange, which is the value of y. And here I'm just going to deduct the dollar sign because it will probably be easier in this case. And from the second sentence, we know that John pays $19 for 5 apples, which will be 5x, and 6 oranges, so there will be 6y, equals 19. Find the cost of 6 apples and 7 oranges. So we need to find the value 6x plus 7y. Well, first of all, we know that y is equal to x minus 0.5, and therefore we can just substitute that into here. So we will get 5x plus 6 times x minus 0.5 equals 19. And therefore 5x plus 6x, after distributing that, minus 3 is equal to 19. And therefore we will have 11x is equal to 22 after adding 3 on both sides and combining the x terms. You'll get that x is equal to 2. So the cost of an apple is $2, and plugging that back in to solve for the value of plugging x equals to back into the first equation to find the value of y, you'll get that y is equal to 1.5. So the the cost of an apple and an orange are $2 and $1.5 respectively. And plugging that to our our given question, which is 6x plus 7y, or in other words, the cost of 6 apples and 7 oranges, you'll get 6 times 2 plus 7 times 1.5. You'll get 12 plus 7 times 1.5 will be 10.5, which will be $22.50. So that will be the answer for question number 3. Let's jump into question number 4. Alright, for the first question, this is the last one and it contains 2 parts. So for the first part, part A, the sum of 3 consecutive positive integers is 2022. Find the value of the largest integer. Right, so let's say the middle number, which is the number between the smallest and the largest integer, be x. And therefore, the smallest number will be x minus 1, since they are consecutive integers, and the largest number will be x plus 1. And we need to find what x plus 1 is. And from the question, we know that x minus 1 plus x plus 1 is equal to 2022. And here we have 3x, and the negative 1 and 1 will cancel. So we have 3x is equal to 2022. And then we have x is equal to 674. So the middle number is 674. The smallest number will be 673, and the largest number will be 675, which is our answer in this case. For part B, the size of each interior angle in a regular polygon is 170 degrees. Find the number of sides the polygon has. And perhaps I'll just recall the formula for the size of each interior angle in a regular polygon. So it is as follows: we have 180 degrees times, in the parentheses, n minus 2 all over n. So this is the size of each interior angle. And if you want the sum of all interior angles, you just remove the fraction here. So that will be that. So we can just set this equal to 170 degrees. Now just eliminate the degrees here, since it won't really help us that after the answer. So I can just multiply both sides by n, and we are guaranteed that n is not equal to 0, since if n equals to 0, then how would you have a polygon with 0 sides? So we have 180 times n minus 2 is equal to 170 n. Expanding the brackets and subtracting both sides by 170 n, so I have 10n, and perhaps I'll just add 260 on both sides, leaving us with an answer of n equals 36. So this polygon has 36 sides, and that is our answer. And that concludes this video, so hopefully you guys enjoyed this. Please subscribe for more videos, and I'll see you guys in the next one. Goodbye.